Hello, this video is about an introduction to logarithms. So as you can see from the page, so far we've been looking at exponential or index expressions and equations, which look like this, and this is just a reminder. We've got the evaluated number at the start in this example. The power or the index is the little number at the top there. It's also known as an exponent or a logarithm, and the big number is the base. What I want you to focus on here is that another way of saying this little number here is to call it a logarithm. And as it says here, a logarithm is simply a power or an index. So we've already looked at index form, which is what this example is written in. An alternative of writing that way is to say that 3 is the power that gives 8 when the base is 2. So we know the base is 2 and the power is 3, and it gives 8 as the evaluated number. Another way of writing this is just to say, using logarithms, log to the base 2 of 8 equals 3. What we've used here is this little reminder. You always put the base down below the word log. The evaluated number goes here, and after the equal sign is the power. Some people like to remember this by using a little circular reminder. And when we do this, we need to always remember to start from the base. So we know our base number here is 2. If we start from the 2 and draw our little circle reminders around, always goes in the direction from the base to the other side of the equal sign. And the way we read this is we go log 2, the base is the base, log 2 of 8 equals 3, the power. So there's a few different ways of remembering that. You can choose the method that you prefer. Having a look at these examples here, we've got exponential form for these four, and we need to write it in logarithmic form. I'm going to give you a minute. I'd like you to pause the video and have a go at writing these four examples on the right hand side here into logarithmic form. Okay, hopefully you've had a go at writing them in logarithmic form. You could choose to use the written version and write it out like this. You could choose to use this version that I've given, or you could choose to use a circular version. I'm probably going to choose to use the circular version for this example. So if I've got 16 equals 2 to the power 4, start with the base, draw your arrows in, and I get log 2 of 16 equals 4. Moving right along. I've got log 10 of 10,000 equals 4. Log A of 1 equals 0. And log A of A equals 1. Here's a general formula for you to get down. Probably a good idea to put it into your summary book. If a to the power y equals x, then we say log a to the x equals y. Using the circle method, and this is why I told you that you needed to start with the base first. You can see this one's written with the base and the power first and then the evaluated number, which is the opposite way to what we're doing up here. So circle method still works, but you must start with the base. So the base is the A, start your arrow there, go over to the other side and back to finish at the power. So we end up with log to the base A of x equals y, which is what we've written here. Now, you can also note what I've got written down here, that exponentials and logarithms are the inverses or the opposite of each other. So when you times by a number and then divide by that number again, you end up with your original number. And logs and exponentials or powers are the same like that. If you take something to a power and then you take the log of that same thing, you end up with the original number. So the example I've got here is a to the power of log a. See how they're the same base or the same power? Only works if they're the same. You can cancel these two out and you're just left with a couple of examples. I'm going to show you two ways you can do these examples using logarithms. And then a third way is to just put it straight into your CAS calculator. So the first example, we can rewrite this as in index form, as if we make this equal to x, because we're trying to find out what it equals. 5 to the power x equals 125. And some people can look at that, and some people might need to work on it a little bit. And we find 5 to the 3 equals 125. So x equals 3. A second method for looking at this problem is to take log 5, which we've already got, and we'll rewrite this number as the same base to the power of 3, because 125 is 5 to the power 3. And when we've got it like this, we've got two bases to the same, which we know using this rule up here, they just cancel out. So we're left with 3, which is the same answer we got up here. With our second example, the first way we're going to do it is by writing it as a power. I'm going to change this into a fraction. which might help you to see what the power might be up there. And if we remember our index laws, if we've got a 5 in the denominator, then it's to the power of -1. X equals -1. Second method, we'll rewrite, first of all, I'll rewrite this as log 5 to the 1/5. Now I'm going to try and write this as 5 to the power something. So 1/5 is 5 to the -1. These two 5s will cancel out, and we're just left with -1. For the final example, one quarter to the power x equals, oh, not x, equals 8. And with a little bit of thinking, we can see x equals -1.5. Second method is log a little teeny 1/4 base, and then we need 1/4 to the power of -1.5. So this whole thing here is the same as 8. 1/4 to -1.5. This quarter and this quarter cancels out, and we're just left with -1.5. Using the calculator for those last 3 examples, we just need to use this key here, the log key. Press it, it lets you put in any base there, so I'm going to use the first example, log 5 of 125, press EXE, and you'll have your answer, which was 3, what we got here. Same thing, you can type in log 5 of 0.2, or you could put a fraction in there, press EXE, you end up with -1. And our final example was log 1/4 of 8, press EXE, and it's giving you as a fraction -3/2, which is -1.5.